So I'll kick off. So hello, as Andrew's kindly said, my name is Roger Armson, and yeah, I flew this morning from Belfast, Northern Ireland, and I've been working with Armada Technologies for the last 3 years now. And just by way of introduction, these are some of the ships that I've been involved in. The one on the top left was built in the UK in 1977. I joined it at that time. And sailed around in it for a while, and then went through to tankers, and then came ashore and worked on that container ship, planning containers, and then worked with that outfit, OT Africa Line, running service down to West Africa. And then in 2000, moved to Northern Ireland. I was running ferries back and forth across the Irish Sea. The one in the middle, that thing there, is a gas carrier. I didn't work on that, but my colleague Alex, who's online, that's a Shell ship, I think. So he was involved in that sort of ship. And this one here, this is a ferry that I ran back and forth across the Irish Sea. And this one here with Irish Ferries is one that we've been working with for about nearly 2.5 years now. So that's what I did. My job was driving them around and then running. And in terms of Armada Technologies, who are we? Well, there's Alex Ratledge. He's the young, good-looking one in the team. I'm the slightly older, but still great-looking. And that's Johan, who's joining us on the 1st of December full-time. He's looking after finance. I do everything that these two don't want to do, and Alex does all the techie stuff. So I do things like, accounts, paying people, legal contracts, project management, all those really exciting things. But so that's who we are. Alex is a trained naval architect and worked in Shell for 10 years. Me, you just heard about me, and Johan is a corporate finance guy. And Alex and Johan met when they were doing their MBA in Oxford. We have a
Mark.
Okay. Alex and Johan met when they first started their MBA in Oxford in September 2021. So that's who we are and why are we doing it? Why are we doing what we're doing? Well, look, if I said to you we're not doing it for the money, you wouldn't believe me anyway. Right? So we definitely would like to make some money out of the company that we're trying to build. But collectively between us, we've probably got 60 years of work within the marine sector in shipping. And if shipping, and there's about 55,000 ships out there, over 3,000 tons, if shipping was a country, it will be the world's 6th largest polluter. And we haven't been very good at getting our act together in terms of cleaning up our act. So for me personally, who's been in it for 46 years, I really want to try and get.
I'm trying to. 1 second, Roger. I'm trying to, because apparently online you're not being heard very well. So I'm trying to change the microphone.
Pause for a second?
Yes, if you could. Let's see.
That's really difficult for me. Once I start talking, I can't shut up. But my wife, thing that she really like, we'll be going to a, Kew Gardens. You meet up with somebody, you just make some random conversation. Next thing you've been talking to for 20 minutes, but I'm getting it here, so it's one of the. Apparently, I do definitely talk too much, so apologies for that. Just while we're waiting, I am from South Yorkshire, which is God's County, of course. Lived in London, lived in West Africa, now live in Northern Ireland. Anybody been to Northern Ireland? No? Right, we should go. I mean, it cost me 50 quid to fly back and forth. Belfast.
At a return?
Yep.
Wow.
So, and that was only booked for last week.
I've just spent £35 for a return to Birmingham.
Precisely. And so if you go out of season, great hotels. So you've got the Titanic, you've got the tender that took people out to the
I
ship.
think, Roger, you can continue whenever.
Oh, there's no talking about Northern Irish tourism is way more interesting. Anyway, we can carry on that later. So that's why we're doing this. And right now there's only 2 of us, but Johan's joining on the 1st of December, so there's going to be 3 of us. But that's not really who we are. So we started off with a grant from Trig, which was a UK government grant. We did some work over in Newcastle University. We got a grant last year from Liverpool City Region, which is European Union. We got grants from Innovate UK, and we're currently part of a European Horizon project, which is running over 3 years and got a budget of €5 million, and we are one of 14 partners. And we work with organisations, as I said, Newcastle University, did a lot of work with Liverpool John Moores. In fact, we're really doing 3 projects with you, because we did Polaris, we did Canopus,
Retrofit.
the retrofit,
And a bit of Deneb.
and we're doing Deneb, and we're also doing the Horizon project.
Exactly.
All our projects are called star names. So Deneb is a star. We work with this company HSVA over in Germany, who have a big cavitation tunnel. We work with EcoClaw, who are based over in the States, Argonavis in Greece. Who else? I'm looking for one of them. Friendship Systems down the middle there. That little penguin based in Germany. So the point is, whilst we're a small company, we work with lots of different people to do what it is that we're trying to do. So that's us, and that's where we got to today. And so, what is it that we do? Who likes air hockey? Yeah, you all know what air hockey is, right? Table, puck, click, click.
Yeah.
We're air hockey for ships. So a ship, contingent on what type of ship it is. So, for example, a full form bulk carrier, up to 80% of its resistance can be due to the friction between the seawater that it's going through and its hull. So if you can reduce that friction, then you can reduce the energy demand on the engine, and you can therefore reduce the fuel consumption, and you can reduce the carbon output. So back in the 50s, the Russians came up with an idea to put some air on the front end of their icebreakers, because icebreakers create a path not by smashing through the ice, but by sliding over the top, and the weight of the ship crushes the ice. So if you can get a ship to go further across the ice, so you make it more skiddy by putting some air underneath it, happy days. And then about 10 or so years ago, a company called Silverstream came on the market, and they put a bunch of compressors on their ship, pumped air below the ship into what they call air release units, and they put a film of bubbles underneath the ship. And they've reduced drag down to 5 to 10% then. So that's what it does. And if you imagine, a ship in space and no forces acting on it, you flicked it, that ship would continue to accelerate until something else stops it. And of course, that doesn't happen if you've got a ship in the water. So that's what we're trying to do, very simple terms. And as I mentioned before, there's 56,000 ships out there. They're all having to reduce their fuel consumption. They're all having to reduce our carbon output. That's something that now become seriously mandated to do. So, but there's different types of air lubrication. I'll come back to us in a second. I'm not at the top, but the cavity-based systems use compressors, and compressors are designed to run for a relatively short period of time, fill a tank up with compressed air, and then somebody opens the tap up and the compressed air comes out of it. These ships rely on operating compressors 24/7. It's fantastic that they've done that, and they've certainly made air lubrication mainstream. I think Silverstream have got something like 60 installations on ships, doing really well. But that's 60 out of 55,000, 56,000 out there, so it's tiny. So definitely the town is big enough for plenty of products, or more products that are in the market today. The bottom one, I'll be perfectly honest with you, I don't know a great deal about that, but it uses compressors and it's a similar sort of thing. We all do the same thing. We're all trying to put air between the hull and the seawater. Our system relies on a Venturi. You all know what a Venturi is? Yeah? For those that don't, anybody got a gas cooker? Gas cooker needs a Venturi to pull air in because, of course, you need air, you need fuel, and you need ignition to create the burning gas. So we use a Venturi so that as the ship moves forward, we push water through the system. The Venturi pulls in the in the air from the deck, creates an air-water mix, and then injects it between the hull and the water, or the boundary layer as it's called, to reduce drag. That's our concept. And we call it passive air lubrication system, or PALS for short. So that's what it is that we are selling. As it says there, we're the world's first compressor-free system out there. We haven't sold many yet. In fact, we've just about sold one. But we've only been in business for 3 years, and we'll talk a little bit about that trail of how we got there from 3 years from basically nothing to where we are today. So I'm not going to talk a great deal about this, but this, what we call first generation air lubrication systems, continuous operation compressor. So there's a lot of power demand going through the system. So your net benefit is reduced because of that power demand. And they're not great for ships that are deep drafted. And they don't really like ships that start rolling around all over the place, because these air handling or air release units, ships rolling really heavily, then the air sort of looks for the least line of least resistance and comes out the air handling unit straight to the surface, and therefore doesn't lubricate the bottom of the hull as much as it was originally designed to do, and therefore its efficiency is reduced. And kind of almost counterintuitively, to increase the ship's drag, they've got to go faster. But by going faster, they're burning more fuel. So at some point, it gets to be a zero-sum game by increasing the speed. It takes up space. And for all you engineers out there, you'll know that if you're running a compressor long term, that creates quite a work demand on your crew. And in fact, these ships with multiple compressors on board require an extra marine engineer to look after them. And for those, you probably know that marine engineers are in short supply, particularly good marine engineers. So, and the other final thing is that if it stops working, it might actually increase the drag, so you might have a drag penalty if the thing's not operational. So, but nevertheless, they've sold them and people are buying them. So, we call ourselves this second generation. And as I said before, it's the forward motion of the ship that drives the water through and creates the drag, or creates the drag reduction. We also, on our system, will have three small what we call low pressure blowers that will augment airflows, and some small pumps that will augment water flows. And I'll explain why in a second, to help the system perform at all sorts of different operating conditions. So this is what our system looks like. So we get this box. This is fitted in the bottom of the vessel. So the water comes in here, goes through here, and then the Venturi's in there, and the air-water mix comes out through here. And these units, or pods as we call them, we can manufacture these. We can have multiple numbers of these pods stored in the bottom of the ship. It's quite complicated. I was talking to somebody earlier on about the easiest way to do this is before you even start to lay the first plate of the ship, you include this in the design of the vessel. Because then it's much easier to fit it whilst you're putting the ship together. Whereas if you do it on a retrofit basis, it's much harder. You've got to cut a hole in the bottom of the ship. You've got to convince class that you can do it, etc., etc. And as we're discovering on one project we're working on, class wants a significantly thicker reinsert plate, if you like, than the bottom than the actual shell plating itself, which is expensive and difficult to do. So it's not an easy proposition to do this on a retrofit basis, but we're doing one next year. I'll tell you anything about that because it's subject to contract, but we're doing one. And it's not an easy task, but we're making good progress on that. So these units here, in fact, inside there, of course, is the brains of it in the sense that it's all about the shape of the inlet and the shape of what's called the transition piece, so how the air-water goes down there, and the shape of how it pushes the air-water mix underneath the hull. And we've used CFD to design that, design its shape. And we're currently in the process of manufacturing those, if you like, bespoke elements for the installation we'll do next year. Oops. And if you imagine, this is the bottom of the vessel. So this is the hull bottom on the tank top, in the double bottoms rather, and these are the pods that you've just seen laid out. So you've got 1, 2, 3, 4, and another 4 on the other side. This was for a ferry that we did the design work on earlier this year. Ferry with Irish Ferries who operate out of Dublin into France. Oh,
It's gone.
Houston, we got a problem.
Yeah, so
It seems so.
Turned off. Anybody seen Apollo 13? No? You haven't seen Apollo 13?
it's like astronauts.
Yeah, you know, it had a major malfunction, and one of the astronauts phoned up and said, "Hello, Houston, we've got a problem." They ended up using they were supposed to land on the moon. They ended up using the thing that they were going to land on the moon on to boost them around the moon and get them back to Earth. Tom Hanks is in it. Pretty good film. So there you go. Probably on Netflix or something.
I have a question about the roof. You know how it, oh sorry, you're gonna fix that first.
Yeah,
No,
continue.
I'm not going to do that. I'm going to leave Andrew to do that. I'm not an engineer. You know, my job was driving ships and stuff. Oh, we had it.
No, I should come back on in a second. If you have a question.
Yeah, I'll take questions while we have this technical interlude.
Yeah, so on the PowerPoint it said the ship ejects the water and air mix.
Yes.
What's the reason for it ejecting those? So like, why would it not just eject water? Wouldn't that also push?
That's a really good question.
So why is air included?
You think that the air-water mix will reduce drag more. However, in the tests that we did over in Hamburg, we found that we were getting drag reduction purely by water going across the Now, my basic level of physics, I think that's to do with the shearing effect between the hull and the water. So therefore, we've got the drag reduction. Here we are.
There we are.
Excellent.
Fair enough, yeah.
should
that
be-
top right. That should close
yeah.
that box down. shouldn't it?
Should be
Just
good to
click
go.
that.
Yeah. There we are.
Wahey.
Okay.
David, very persistent.
Yeah.
So coming back to this is based on an Irish Ferries vessel. We did a lot of work with them this year, starting in early January. This was a project partly funded by Liverpool City Region and by the European Union and by our own shareholders to essentially design a system to put on their ferry. And this system only has 8 pods because the ferry is quite a fine-lined ship, because of course the ship needs to run around at about an average of 20 knots and about 6.5 meters draft. It's pretty consistent compared to, say, a bulk carrier that would be operating, say, 12 knots on a draft range of, say, 11 to 18 meters, contingent on whether it's full or whether it's in ballast condition. Because with a ferry, whether they're full or empty, the draft doesn't vary that much because the actual weight of the cargo on the ferry is relatively low in comparison to, say, a bulk carrier. And because the ship is fine-lined, we can only fit 8 of these systems on the hull. Whereas on a on a bulk carrier, we'd be looking at something like 14 of these units. So, key benefits for us: compressors. We want to have a very flat operating curve. What we mean by that is, I mentioned earlier on about the pumps and the blowers. One of the problems with current first generation systems is that there's not much they can do to tweak the way the system operates, contingent on the operating conditions of the ship. What I mean by that is its speed, its draft, its trim, and weather. Whereas we believe that utilizing small pumps, 1 pump per pod, so between 8 and 14 pumps, and 3 blowers, we think we can tune our system contingent on the operating conditions of the vessel. So from an owner, if you've got a system that is really optimized for only one, say, when the ship's full, well, half the time it's empty. So half the time you're not getting optimal use of the system, whereas we believe with our system, we can get optimization for a much greater period of the ship's operating life. So that's the theory. And what we're also doing is, so we've got the mechanics of it, the pumps and the blowers and the water flowing through the system. But we've also this year, we did a milk project to basically build a brain for the ship to soak in data, so we can collect a lot of data from the ship, how, what the demand on the engine is, how fast is it going, all that sort of stuff. And go, well, hang on a second, if we just tweak that pump up a little bit that way, does it improve the performance of the system at this particular draft and this particular speed? So over a period of time, we can train it and teach it to operate the system in the most efficient manner. And we're working with a small bespoke consulting company down in London who has somebody who is a real expert in AI and how it applies to ships and in particular lubrication systems. So that's what we're trying to do. And we think we can do something like 10 to 12% net reduction on fuel. And that's significant. In my career of running ships, I've had a lot of people selling me systems that they claim are going to reduce fuel consumption. And if anybody came to talk to me and their fuel consumption was less than 3%, I wouldn't give them any time, because when you get below those numbers, it's very difficult to measure. You know, you need something north of 5%. If we can do something like 10%, then we think that A, it's going to help the maritime industry significantly. B, people would want the product. And even if
tomorrow, all the fuel that was being burned by the maritime industry became green fuel. Systems like ours would still be required because the amount of energy that you get per ton of fuel you burn on green fuel is way less than hydrocarbon. So, people still going to need this. And the numbers that I've heard to go green for the whole industry is something like $1 trillion. I'm not math. I know a bit about maths. But I'm not even sure how many noughts would be across that screen for $1 trillion. It's a lot of dough. And as our system, we don't have compressors, we think it's easier to look after. We think that it's relatively easy to install compared to other ones. And we think it's going to optimize across a whole range of different ship types. And this is when we start to talk to owners. This graph here was prepared by our colleagues in EchoClaw, explains what the power demand is. So there you've got these big compressor ships running all the time with their compressors, whereas our system, we're going to need the pumps and blowers to operate some of the time, but not a lot, because we're going to optimize the system to operate in a passive mode for as much of the time as possible. So we think that we're going to have an edge on power demand. And as I've said, we think it'll benefit from these wide ships. This thing called belching. This is what I was talking about. If you imagine, ships going like that, and it kind of burps out the air. And we think we'll get a more even, consistent delivery of drag reduction. Container ships, fine line ships. I mentioned about the ferry, very similar to container ships, LNG types, cruise ships, all that sort of stuff. So how did we get here? So last year, we, well, even going back early, 2021, we went to Newcastle University. They've got a cavitation tunnel. We got a grant off the government. We made a small-scale model of our system. We stuck it in the cavitation tunnel. We turned on the power, pushed the water through the model, and it was amazing. And our water mix came out the other end. Worked. And then that cost 30 grand, 30,000 sterling. So, and if you pay tax here, what do you do? Thank you, taxpayer, because the government paid for that one. We then went to HSPA, and the cost increased by tenfold. So the biggest problem we had, a lot of small business had this problem. My business partner, Alex, calls it the valley of death, to find the money to get to that 300 grand test. But we got it. We did it in Germany. And here we go. So we did the test, and basically what the test did, we got a 8 by 2 meter steel plate, which is replicating the bottom of the ship. We even painted it with anti-fouling, same as on the ferry. And we built, or HSBA built for us, a full-scale replica model, or a full-scale unit of the Venturi and the injector. And then we pumped water through it to replicate the ship going through the water. And oops, let me just go back. Can you press that button to make that video go?
Which one?
No.
It won't work.
It doesn't. That's a PDF. This is a PDF. That's annoying. Apologies. However, we can, if we get time at the end, I've got it on my computer, and I'll show you this video of the bubbles, But over a period of a week, we tested our system in Hamburg, and we got drag reduction significantly above 10%. Now, that's in a tank. But it's the best test. Even if we'd have had 3 million quid, you can't get a better test than that. And when we go to talk to owners say, well, get more proof. So that's an issue that we've been facing. And we were very fortunate. Alex did a lot of really good work with a particular company, and we're quite close now to put it on the ship. So that's part of our development. We're working with Liverpool John Moores on this Horizon project. Andrew in particular. And in fact, Andrew was in the over in Hamburg with Alex, and Milad was there, wasn't he?
Yeah,
and
exactly.
Mark from Echo Claw. So yeah, and I even got to go for it. So we had a good team over there. We're now working on the Horizon project, which starts on the 1st of January. And the big thing that we're doing is we've got a couple of models. This is the container ship, and I'm sure whether there is. Sorry. That's the container ship. We've also got this Japanese bulk carrier. And what we're going to do with those two is that we are going to put them in a tow tank at CNR. It's quite a big tank. And we're going to simulate our system on those two models. We're going to test without the system. Measure the drag on the hull, and we're going to put our system in. And we are going to put the system on and then measure the drag reduction. Of course, you may be thinking, well, how are they going to scale the bubbles? How are we going to scale the bubbles?
A lot of work. It was part of my PhD research as well. So hopefully, whilst we're in CNR, we can replicate this test in CFD, and then we can prove my PhD and continue adding to it to scale up to full-scale results. But it's quite a process.
And we're going to use nanobubble generators.
Exactly.
So the idea is use nanobubble generators, but we've got to have up to 14 pumps, haven't we?
Exactly.
In fact, here's the problem I've got with academics, right? I figured it was going to be relatively cheap. What's your budget at the moment? How much do you want? Like 90,000 quid?
Yeah.
So, it's not a cheap thing for us to do. And even though we've got a Horizon, sorry?
Who else can do it?
Even though we've got a Horizon budget, it's still a lot of cash that we've got to pay 40% of that. So, so that's probably the biggest lump of work that we're doing.
Exactly.
And we're designing the system now. And the interesting thing is that the design work on that is not, it's still really complicated and a lot of work, not dissimilar to a lot of the work they're doing on a full-scale ship. And a lot of the documentation is precisely the same as if you're putting on a real ship. So, these things aren't easy to do. But we're working with Liverpool John Moores, we're working with CNR, we're working with a company called Friendship Systems, who are doing the CFD. So we've got a really good team that we're working with. It's a real privilege. Yeah, we hope to do the test next year, and then we'll spend a fair chunk of time analysing those results.
Exactly.
And I think, for you did a PhD, I think you're doing a PhD, data and having the ability to compare real life to model testing and CFD and all that stuff is what we're looking for. And the amount of data that's on air lubrication systems, real life compared to tank testing and all this other stuff, is tiny. In fact, I would use the word minuscule.
Exactly.
And I would also say that I'm not an expert on bubbles, but I've learned a bit. Our knowledge on bubbles is still pretty small.
Very small.
And we've got two experts here in this university, Andrew being one and his colleague Milad Armin, both doctors, who know a lot about bubbles. In relative terms, don't get this the wrong way, but that's still a tiny amount in reality.
Exactly.
So, if you want to get into something that is not a lot known about it, and it's going on right here in Liverpool. You could do worse than looking at bubbles, in my humble opinion. So that's the big chunk of our work. There's all sorts of other stuff going on with the Horizon project. Its target is to get a 35% reduction in fuel consumption on a ship, which is huge. You're not going to get that from one thing, right? You're going to get it maybe from a lubrication system. We're working with 2 companies that do wind assisted for vessels. We've got electrification, and we've also got, if you like, a system that will say, okay, you've got a bulk carrier. If you add ALS, wind assisted, and whatever, we'll run those ideas through this magic box, and it comes up with, you'll get 22.5% drag reduction, sort of thing. Is that about right?
Yeah, exactly. That's exactly it.
So that's the main thing about this, the Horizon project, because whether we like it or not, we've got to stop burning carbon, or we've got to stop producing carbon. So there you go. Actually, it's 55%. There's a bit of a debate as to whether it's 55% or 35%. I always thought it was 35%.
It should be 55, but even 35 is impressive. So
I mean, if we got 35%, happy days. And I have to say, it's when we first started the work, or before we even started, we put the bid together. Started putting the bid together. Was it last February? Wasn't it?
I think January last year.
January last year, and we got knowledge of winning the grant. I think it was July or September last year. September last year, and then we started the project on the 1st of January. And having 14 organisations in that operation, I was thinking, how is this going to work? But we've broken it down into, I think it's 9 work packages, isn't it? 9 work packages. That works really well. So Milad from Liverpool John Moores runs the work package that is Armada is all about the air lubrication system. So we've got a relatively small team, so we can make it work. And there's quite a bit of cross-fertilisation between the work packages. But yeah, what I would say is, any of you thinking about going into a Horizon project, you need to have somebody within your team who really understands how the admin works. I overheard you talking about administration earlier on. The administration of these Horizon projects is a whole job of work, 6.5 days a week for one person, I would say.
That's pretty much.
Alessandro, that's what he does, right? And good luck to him, because there's no way I can do that. So that's the retrofit 55. Oops. And as I mentioned already, what we're calling here our DDS, Decision Support System. It should be DSS, shouldn't it? Mind you, DSS, what's that? Department of Social Security.
No idea.
Used to be. I think that's it's past now. Or as a friend of mine called it, the Department of Stealth and Total Obscurity. But anyway, so we're looking to, as part of this, to model these various different solutions, which is what I was talking about earlier on. So if you're an owner, say, right, I've got a particular ship, what's the best mix of kit that I can put on my ship to get the best return for my investment? So those are the advantages of our system. And when we go and talk to owners are interested in, first question is, okay, so how much is going to reduce my fuel consumption? Second question generally is, okay, so how much is it going to cost? Third question is, how long will it take to fit? And then they can go and work out, well, if I spend $3 million to buy and fit, I'll get my money back in 3 years or 2.5 years, something like that. Because if you're going to invest in something that is new and radical, and we all know how quickly today's technology becomes last year's technology in the bin, if you're a finance director, you want to get your money back as fast as possible. So that payback is really important to our customers and potential customers. And one of the reasons that Johan is coming on full-time in December is that there's a lot of work on that fiscal side, if you like, to be able to convince somebody to stick their hand in their pocket and give you $3 million. but we think we can do that. So that's us. I'm Roger Technologies.
I have one question.
So thank you very much for listening.